Good morning, everyone. Happy Wednesday. I hope that you've been having a great week. I'm looking forward to continuing the ecosystem project and getting some of those walkers on there and eating some food and doing some awesome things. I'm gonna go ahead and set up my chat over here so I can read that. All right, perfect. Got that over there. Let's see where we are. So last time, I believe I set up. I basically set up some food, and I was gonna have it randomly move around. And then last night, I sort of had some ideas to maybe like put a bunch of food down, and then instead of shrinking or fading away as we die, as they run out of energy, more of just what if I don't have the food renew? And so you can eat all the food, but then you have to eat each other to survive, and then the last one wins, and then that's kind of it. So I want to start with food just sort of randomly sitting around. And I was thinking of doing like 100 of them around like that. So if we start, take a look at what we have. Here's our food. If let's say maybe 50, I don't know, 100 might be too many. Also, if I set the radius to be 1, so like very, very small. I'm also curious to be whether or not this will be visible properly. Location, so it's going to be, around the arena, but not too close to the edges. And I'm not going to give it velocity or acceleration. I'm just going to have entity, so with health, with location. Also, I had like as Danny Fritz mentioned last time, I did have my velocity and my acceleration backwards. But we can fix that in the because we have this reset acceleration, that's fine. Update location. Yeah, location plus acceleration. This is wrong. Yeah, so we have these being wrong. So I'm thinking I'm just going to remove them to force myself to do them properly when the time comes. Okay, and then here. So no updates happening. Instead, we have, we're just going to draw it out wherever it is. And we'll just start with tiny little green specks. I think I want color to be added in here too, because I don't have that. I just have this create entity with health, with location, with radius. Then down in draw system, we're setting these to be green. That's not going to fly for very long because I'm going to want. I'm almost thinking of just random colors, and that's kind of what I want to create. So what if I create a new component for that? Okay, so struct color, and this is going to be a just store graphics color. Implement on color. We don't take anything in. We're going to return a new color and color. And here we can do UVGZZ, color, random, probably random dark color. And then we can use that. Oh, you don't exist anymore. Oh no, you still exist, yes. Okay, so with that, with radius, dot with color new. All right, so that gives us the color. Then down here in our draw system, we're also going to read storage color. Color, okay, and then down here, instead of this entire graphics color new, we can just say color. And what are you upset about? Mismatch types. Found. Okay, so I need to dereference it, I think. Oh, it's sorry, it's color.0. Keep on forgetting it was a tuple, so I need to dereference it. All right, so if we run this, we should get 50 little tiny dots of random colors all around the arena. And I can't really see those. I don't think you're going to be able to see those either. Let's try upping it to 2. I can also make it a random bright color. That might help. There we go. So now we can see all the food sort of lying around, and so my thought is, as soon as they're gone, like they're gone. And then these can almost be like, we can almost see these as the drops. Since I'm kind of mimicking a battle rail type thing here, these are the drops. These are what you use to sort of level yourself up and get ready to go. So like free, easy food, as it were. All right. So if I have this, then I'm going to want to create our random walkers. So what's a random walker? Well, we can do 5 of them again. So these, add food, add random walkers. All right, so 4 in 0, we'll do 5. So world dot create entity dot width. Okay, so what do our random walkers have? Well, we know that they have health, food calories. So everything starts at, so I guess like everything starts with 1. And do I want it so that when you attack somebody, oh yeah, you get whatever calories you've eaten. So like that will like be increased. So with health, food calories. Oh, it's just upset because I haven't finished it. We also know we need a location. And I'm thinking a random location would be good too. So it's, I kind of just copy this. With radius to, so like, I think that's fine. We can start with the same size. And start with the same color. Okay, so here we go with this. Actually, since everything's the same, let me just go ahead and copy you all. There, I had screwed up somewhere in my copy paste. Okay, well, that begins okay, but we're also going to need everything else. So we're going to need our velocity, our acceleration. So we have location. So location is going to be updated by the velocity, and the velocity is going to be updated by the acceleration. And then we're also going to have like the force, the speed that it moves at. Crossbow, good morning. Okay, so velocity, acceleration. Start with velocity, new. Dot with acceleration, new. Okay. So this should add the 5, around. They're in the arena. Then what we're going to want to do is start creating our systems to move them around. And I think actually, yeah, we now have lots of food lying around. Random movers moving around randomly. So I'm thinking do we need a speed? I think we need a speed that everything can move at properly. So let's create that as a component. Struct, I'll call this speed, and this will be a F32. Okay, so we got our speed there. That's now added in here. Speed, so I don't really know exactly what I should put this to be, so I'm just going to make it a 10. And we can sort of play around with that in the future. Okay, so how do we move in this game and do it properly, unlike last time? So we have our location. What we want to do is we want to apply a force, sort of like a tap to it in a random direction, and that applies to its acceleration, which then gets added to its velocity. The velocity then gets added to the location. The reason why that then works is at the end of every round, we reset acceleration. So that way, velocity can like potentially grow infinitely, but acceleration cannot. It's like whatever the forces that are combined. So if we have like wind and like a tap and anything like a balance, everything else like that, that's what the that's what's happening with acceleration and velocity. So let's give ourselves a tap to the acceleration using our speed. Okay, so this is going to be a struct random move system. I guess that's all. So we now have to implement system for random move system. All right, what do we need in here? we need our speed. So read storage speed. We also need we need to write to the what is it called, the acceleration. And I think that's going to be it. For right now, I believe we're doing, I guess, like, we're creating RNG here, and we don't necessarily have that stored anywhere. So we can do that at a later time. In a way, I could pass in RNG, but then I don't know if I can pass in a reference to it, because like it's in a thread, so it would be it'd probably be upset about that. Let's go ahead and just not worry about it too much right now. All right, so just speed and acceleration, we're gonna get a random direction. So let's see, function run self, then we have our speed, mute acceleration, we're going to use join. Then we're going to, we need to get our the entire RNG. So we do this. We're going to now do our loop through anything that has a speed and an acceleration. Okay. So for all right, so now we can create a random direction, so to say, and I'm thinking that this could be normalized, so between -1 and 1, and that's going to have to be for the x and the y axis, and then we can apply that to the acceleration. So we're going to create a force. This is going to be a vector 2. And so for the x, it's going to be RNG gen range between -1.0 and 1.0. And we'll do the exact same thing to the y. Now that we have our force, we're going to add that to the acceleration. So we're going to say acceleration.0 plus equals the force. Now, before I necessarily want to plus equal the force, or maybe I do, at this point in time, I want the force to be multiplied by the speed. So that's just gonna be speed.0. And that will bring it up to move at the actual rate that we want it to move at. All right, so random move system, let's go ahead and run that in update. All right, that gives us, so now it should randomly move. Oh, right, you need to be mutable. Okay, so let's see if, now I haven't, this just updates the acceleration by applying the force to that. We need to also update the velocity. So that's going to be another it's going to be another system here. And now in this one, are we going to need, no, I don't think we're going to need our delta time for this yet. This is still just an add. Actually, it's going to be it's going to be similar to this. Do type. All right, so we're going to have our read storage, which is the acceleration, which we just updated here. And then we're also going to have our write storage to the velocity. Okay, so acceleration, mute velocity. Do use specs join. We don't need random in this one. We just need to update the velocity system. So what is that gonna look like? It's, I think this is gonna be as simple as velocity.0 plus equals acceleration.0. That's pretty much gonna be it. I forgot to join you. Oh, I didn't run our for loop. So for now we can do velocity.0 plus equals acceleration.0. There we go. So now our update velocity system, we can now run in here. Okay. So that's going to give us, our velocity is updated. Now we need to update our location based upon the velocity. This is actually going to be pretty much the same as what we have here. We're just going to change, nope. Going to change you to update location system. All right, so we're going to read storage. This is now going to be velocity. And the write system. Oh, okay, hold on. Write system is going to be location, function mute, So we're going to have our, what is this? This is our velocity, mute location, velocity, location, in velocity. Location, and then location dot 0 plus equals to velocity dot 0. All right. Update location. Okay, so we update the location, and then the final thing is to reset the acceleration. So if I copy you, reset acceleration. So we don't even need read storage to velocity. We just need our write storage to acceleration. So you are just going to be our mute. Come on. Acceleration. Specs join. Acceleration. Acceleration. And now we're going to say acceleration dot 0 times equals 0.0. So that way we just multiply it by zeros. The x and the y will be individually multiplied, and that will reset it to nothing. You don't need the parentheses. Is it possible to have physics system to encapsulate location speed and acceleration in one system? You know, probably. I probably could. Where like I have essentially like the actual move part. But I bet that I could. Let's go ahead and get a reset. Let mute reset acceleration. Reset acceleration, and we'll run it. All right, let's see if we can get like 5 of these moving around randomly. I didn't use the delta time, so that's they're gonna be really fast. And so I saw them moving around. They just, yeah, they're way too fast. So our update location is gonna have to take in the delta time. And so the question becomes, can I just have like a single physics system that then updates? So like random move updates the acceleration, but then once we have the acceleration, we know. Then yeah, I don't see a reason why we can't do that. So we can just so update these two can go away. Update velocity system. So random move, let's do this to physics system. Okay, so physics system. Okay, so what do we need? We need to the acceleration, we don't need to, oh no, we do need to write to that. So we need write storage to acceleration, write storage to velocity, and write storage to location. Okay, so you are going to be mute to acceleration, mute to velocity, and mute to location. We're going to join together location. You become mutable there. Yeah, so physics system method will do all the other, like we'll do all the calculations we need. All right, so what are we going to do here? So we need to take our acceleration, which was updated and whatever previous sort of force that we applied, and add that to velocity. So we're going to say velocity.0 plus equals to acceleration.0. Once we have that, now we're going to update the location. So location.0 plus equals to velocity.0. And then finally, we're going to reset acceleration. So acceleration.0 times equals 0.0. All right. But a problem here is that we need delta time. And the easiest way to get that is to say that our physics system is going to take in an F32, which will be our delta time. And when we update, so velocity, we're going to multiply the delta, so it's going to be self.0 when we update the location. All right, let's do this. So physics system. Okay, here it is. Okay, so let mute physics equals our physics system. And so now we need to get the actual like delta time here. So we're going to need timer. I think that's in here. Okay, so we're going to say timer. Oh, okay. So we need, maybe instead of doing it right here, we'll do it out here. So let delta equals timer delta. So get the time between the start of the last frame and the current one. Right. We then hand it the context. We now want to convert. So this is delta is now a duration. I'm going to convert the duration to an F64, I guess. And at the very last second, we'll convert it to an F32, maybe. Or I can just can I say delta dot right as sex F32? That's what I want to do here. Why do you need to do multiplication with 0.0? Isn't that the same to make it equal to 0.0? Yes, absolutely. The reason I want to do the multiplication there is I want to set acceleration back to 0. So have its x be 0, have its y be 0. I guess I could also have a method on it called reset that would do the same thing inside of there. But the idea is that every single tick, the acceleration gets reset, so it just doesn't like infinitely go on. infinitely get faster and faster and faster. All right, so we create our physics and we randomly move, and now we're going to physics.run now self.world. So let's see if I've got this working. And can you see that? We have a bunch of random walkers. Now they can't, like, they all just left the arena. So that's not necessarily fun. And we have to make the decision. Do we want to make it so that you can't leave the arena, you just go to the edge and then you get stuck there? That's what I'm kind of thinking of doing. Maybe like when you hit the edge, we can even reset your velocity, so that way you're not continuing to move into the edge. That might be interesting. But this is random walkers moving around randomly. The walkers can eat the food. So I want to make it so that if you touch the food, well, if you envelop the food, I guess like if the center of the food is within your own radius, you then eat it and you grow by whatever its health was. So that means we're going to need some kind of like eat system. And it's really just going to check to see the other entities. That's all we really care about. All right, so we have eat system. Oh, I don't need this. Implement system for eat system. Basically, they can eat each other. Like they're all entities. They can just eat each other. All right, so eat system for eat system. The only one that they can't eat is themselves. So I don't think that's going to be a problem. I'm going to do type system data equals, what do we need here? We're going to need the location. So we need our own location. So read storage location. We also need our own size. Oh, it's radius. Radius. When we eat, we have to increase in radius. So this is actually going to be a write system, write storage. We need our health. So we need write storage to health. And this is where I'm thinking that our health and our size should probably just be the same. Because right now I have like food calories. Well, okay, I see what this is. Our initial start for size is different than the health. And I can see that, like, we're starting differently. But it might be better for us just to make this start at 2. Come on. Then instead of health being added in here. We don't need this at all. So health goes away. Actually, maybe we keep the health and we get rid of the radius. That's what we can do. So we keep the health, we get rid of the radius. We start with health, like everything starts with 2 health. In our draw system, we don't need the radius, we need the health. And that should be the same now. All right. But in the eat system, we're not going to get the radius anymore. We're just going to get the health. Should remove the actual radius component. All right, so we're going to write storage to health so we can increase our health, which would then increase our size. So we need our location, our health, which is our size, and then we also need all the other entities to find out whether or not we're actually eating them. So this is a little bit interesting here. We need to get entities. All right, so entities, and I think that's how we do it. I should verify. All right, so specs. Accessing entities. So bring in entities, yep, just A. And then I think there is a way to join together all the entities. This is not that. I'm going to join entities. Joining components. So this is entities, Danny Fritz. Why do you want to join entities? Entities is a resource for managing removal and creation of entities. I need to get all the other entities so that I can eat them. That's the big thing that I need to do. So if I look through this, we have our other entities. Maybe everything with a position. Well, I guess like the problem is this is just going to be my own. So I need to do, in every loop, I need to do another loop. But let's get to it, I guess, first. So function run self, our location, our health, and then all these other entities. I don't think it needs to be mutable. Self to system data. Okay, then we go to 4. All right, so we have location, health, we're not going to bring in the entities at this point in time. In, so it's reference to location, new reference to health, join. All right. So at this point in time, I now need to take our location, get the distance between every other another entity. So like loop through all the other entities. And oh, not self. Specs join. All right. So we need to get the distance between ourself, like whatever entity that we're looping through right here, and then each of the other entities. So we need to now loop through all of the entities and get their locations. So I remember we did this in our test. And I could just go look at that, see what we did, because we got eating working there. Is this entities values? You want to filter your selection. Here's all the entities that I can, I guess, join together. You double for looped and recorded an effect. Death later in a system, right? I remember I double for looped. I just can't remember if I needed double for looped. Again, because I need to know like if the entity is myself. Like I don't know how to get mine. Let's just go take a look. Let's go take a look at it. Was this in my own? Oh no, I think it was in Brooks builds. Learning specs GGEZ. Okay, here was our eat system. So we brought in the entities. So position size entities and then grow. Might want to create a walker tag component and a food tag component. I'm just gonna have them eat each other like purely, so I don't think that should matter. Okay, so for my position, my size, me. Okay, so entities. So we have to get myself in the entities and join that. Okay, so for location, health, and then I send essentially like myself in entities. Then we do another loop inside of here. So other position, other size, other entity in exactly the same loop again. All right, so for the other location, other health, and then other entity, or I guess like I just say other, and so here is going to be our reference to location again, a reference to the other health. I don't need to take it mutably, and a reference to entities. All right, so only if we're not, it's like myself is not myself, I guess. This shouldn't be other health. This should be health. Oh, I don't need. Oh, okay, hold on. This needs, because I'm losing which ones these are. So these need to be my location, my health, and myself. For other location, other health, other location, health, entities. Now, what are you upset about? Cannot borrow health as immutable because it's also borrowed as immutable. So that's a problem. What did I do here? Oh, okay. So I had this like entire grow by component. Yeah, okay. So I have to have a grow by component as sort of like the shell game to go between them because I can't just grow directly in here. So this is because I can't borrow it both mutably and immutably. And if I try to borrow them both mutably, it won't know which one. And so it won't, like this is even worse. This is, you can't borrow it twice. So this is gonna have to be read storage. Oh. Like that. And then also I'm gonna want to create another component that's going to allow me to like grow it by a certain system amount. So let's try grow by. I think that's fine. It's not that. Component. Struct grow by. And this will just be an F32. We'll register this. Grow by. And then the food doesn't need to grow by, but the random walkers do. Grow by, and then this is going to be 0.0 as our initialization. All right, so with our each system, we're going to get this entities, write storage, grow by. You grow by there. So grow by here. Grow by here. Oh, grow by, like that. Before I forget, which I already have forgotten, I'll activate our line highlighter. Okay, so now that I have this, I'm not going to use grow by inside of here. So this second one. So now I can properly do what I need to do. Okay, so if I am not, so myself is not equal to other. All right, so if I am not equal to the other, now let's go ahead and check to see if I can eat it. So I want to get the distance between myself and the other. So let distance equals, this is going to be my location dot 0 minus other location dot 0. All right, so that gives me a vector of the distance. I now want to check to see, I need to make this, or what is it? Oh, I need to get that's actually just, it's not the distance yet. It's the, I need to get the magnitude to get the proper distance. So this is going to be an F32, so I have to shadow this. So distance is now going to be equal to distance dot magnitude. So that makes distance be an F32 now. Yep, there we go. We can now tell, so that's the center of ourselves to the center of the other. If that is smaller than our own health, then we should be able to eat it. So if the distance is less than, I guess it's going to be my health. So if it's less than my health, now go ahead, we're going to eat ourselves. So we're going to have grow by. So grow by dot 0. We're going to plus equal this to the other health dot 0. And we also need to register the other entity to kill it. And so I vaguely remember there was a weird thing you do. Yeah, it's going to be entities, so the full entities dot delete, and then the other entity. And so we have that right here. So entities dot delete, and then the other dot unwrap. And that should make eating possible. Oh, right, by health.0. All right, so that should kill other entities as it moves over them. What is the my health? No, nothing. Not anymore. I've got it. Why you use health isn't you need size radius. Oh yeah, so I switched up. I removed the size radius, and I'm only using health as the size. So it's kind of like the stand-in for the same thing. It's like we take a look at our draw system here. We're bringing in health, not the radius, and then our size here is that. That's our radius. We need a grow by system to properly implement that. I can't actually this has to be a completely different system now. But let's go ahead and run this first. Eat system. Set mute eat system like that, and then we're going to run it. And then we need to actually grow. So grow system. All right, so what do we need here? We need our health. So this needs to be mutable. So write storage, our health. And then we also need grow by, and we need this to be write storage too, because we need to reset that in here. So this is going to be our grow by. function self mutable health and mutable grow by self system data. Oh, function run. I missed that. Function run. This all needs to be wrapped in parentheses. Okay. So use specs join for, okay, so now we're going to bring in our health and our grow by. Okay, so now we get to say our health.0 plus equals to grow by.0. And then we want to reset grow by.0 and just set this equal to 0.0 again. To reset that. What are you crying about? Method run has mute self. Oh wait, you go in here like that. All right, so then we're gonna use our grow system. Grow system, and then we'll run it. All right, let's see if this works. Now, I guess like one of the problems is with these sort of, okay, well, that was interesting. I think it got like off the side of the screen, and then something weird happened with the distances, and so it just started growing infinitely. But I couldn't see it. It was like off the screen when that happened. That one ate a lot. Yeah, it did. And I can't, it's not happening now. So I have no idea. I guess the other problem here is that they're not necessarily finding any of this food to eat because like it's a really low chance that they're going to. Is grow by being reset? I was trying to reset it. So here in our grow system, we're setting grow by to 0.0 again. So we are resetting that. I think one thing I can do is I'm going to contain them to the, well, there's a couple things I can do. I'm going to contain them to the arena. And then I'm also going to force the, like add the number of food. So that way they have a higher chance of eating it. So we can do struct contain to arena system. All right, so type system data. What do we need here? Katali, good morning. Hello. We need to know the arena size. I think that's a, yeah, so that's a world thing here. So we can just read the arena size. So read to arena size. we're going to need to know our own location. So read storage location. You know, we probably need to write storage because we're going to need to update it just like that. Write storage. Our own, so write to our own location to just modify it just a tiny little bit. We're going to need to write storage to the velocity. I have a plan for this. And I think, oh, we need the size too. So we need read storage for health. All right, so function run self. Then we're gonna get the arena size. We're gonna get mute location, mute velocity, and health. System data. All right. So then here, use specs join for. All right. So arena size, location, velocity, health, in. All right. The arena. Oh, arena size. We don't need to loop through this. There's only one of them. That doesn't get looped through. In this case, how for hue, we're gonna get mutable location, mutable velocity, and we're not just a reference to health. All right. Okay, so this gives us location, velocity, and health. We loop through them. We now want to see, okay, if we're, I usually start to like the right. If we're to the right of it, then we need to reset. So if our location dot 0 dot x, and just to sort of help out with this, let me see if I could switch over and use my whipboard. Okay, so we have our arena. And I now have a walker, and let's say it goes like this, and it's over the right-hand side. The middle of it technically isn't over the right-hand side, so therefore we're going to need to do a little bit of calculation and say, okay, wherever the location of this is, plus your radius, if that is greater than the width, then we're going to move you to the width minus the radius. Okay. And I think we're going to have to do radius divided by 2. There you go. We're going to have to do radius divided by 2. So, okay, if location plus, if the x location plus the health, so it's health.0 and divided by 2.0. So we're going to, that should do that in the right order. If you are now greater than arena size, and I think it's like a width height, so .0 for the width. We can actually go take a look at the arena size. Yeah, F32, so width, height. Y divided by 2. Oh, you know what? You're right. Probably don't need this. It is a radius. Yeah, not radius diameter. Okay, so. Good call, Katali. So if that's greater than the arena size, then I want to now reset. So we're going to say location.0.x. We're going to set this to be the arena size.0 minus health.0. Okay. That's the right-hand side. We can do the left-hand side, which is going to be an else because it can't be moving off the right or the left at the same time. Also, I'm just going to like stick them there. The other thing I want to do is I want to freeze the velocity. So I want to say, okay, velocity.0 times equals 0.0. So I want to like just reset you. You just hit there and you plunk. Now you can move left easier. All right, so else if our location.0.x, this is going to be minus health.0. If that is less than 0.0, you're to the left of the screen. Now we want to say location.0.x equals health.0. And we also want to reset velocity like that. And I want to do this exact same thing for the y's. So, no, too much. Okay, so y, and I think instead of arena size dot 0, it's now going to be arena size dot 1 for the height. I don't need the if in the else if. Wait, I can just do this and it will be an else if? Oh, it's very upset about that. I think I need that. Yeah, it likes this. It's okay with this. So this should keep everything inside of the arena now. So let's go ahead and contain and run the contain. I suppose you don't need to multiply by 0 either. I'm multiplying by 0 to freeze the velocity. And so since this freeze the velocity, and that's going to make it so that it doesn't have any like momentum going in like trying to go out of the arena. It is not the same thing as equal to 0 because the velocity is actually a vector. So this is like an xy. So in order to do the same thing, I would have to say velocity.0.x equals 0.0, velocity.0.x .y equals 0.0. So that's the reason why I'm doing that. I could add in like a method to like dot reset. That might be better and like a little bit easier to see. Okay. So let's go ahead and use that. So let mute contain to arena, contain to arena system. All right, I think that will work. You're just doing your best to follow them? Well, absolutely. Also, we, feel please ask any questions that you have. I love to sort of like explain what I'm doing, especially if I'm going too fast. You're wondering if I should multiply them by -1 to like make them bounce off the arena a little bit? Okay, so they're being contained now. So that's good. They can eat each other, so if they hit each other, they will eat them. I am not seeing any of them potentially eat anything right now. But it is kind of fun to watch them like bump into the wall, stop, and then like continue moving again. Ooh, okay. So they ate something and then it just never stopped growing. So that's a problem. So what happened there? in our eat system, we deleted the other, so I think that was fine. My grow by, I increased that by the other health. So that should be 2. So it grows by 2. So I start at 2 size, 2 radius, and I grow by 2 radius. My grow system, I'm resetting grow by, so that shouldn't be increasing by too much. And my grow by is set initially to 0. I'm not exactly sure why. Like what happened there? Let's have just one random walker. And let's make like, I don't know, 200 food. So we can watch this a little bit careful, like a little bit more careful. So here's our walker. Maybe I need even more food for it to, like, you know, actually eat it. Okay, that grew by the appropriate amount. It didn't make the other entities disappear though, I notice. Yeah, so it's not, that's the problem. The delete isn't working. So when I tell it to eat, entities.delete the other, this isn't actually deleting the other entity. Am I calling world.maintain? I should be. In update. Oh, I'm not. That's the problem. Self.world.maintain. I totally forgot about that. All right, let's try this again. Where are you? Here you are. I should, like, everything should just work now. So I should be able to add in a whole bunch of the other walkers. So let me do that so we increase the chance of them eating something. We can add in like 25 of them. Like, okay, yeah, I saw this one eat some food and those disappeared. So perfect. They're not growing forever because they're not sitting on top of food that was already eaten, but then trying to eat it again. So perfect. So this is working out pretty well. Oh, they almost ate each other. These two. But that's sort of like I think that's sort of like the perfect thing. There we go. Now it ate another entity. It's looking like a petri dish of pond water. Yeah, I can see that. All right, so we start with these. What is next on our list? So walkers can eat food. Keep everything in the arena. Now we want to add a walker that moves towards the food. All right, so This is where we're gonna run into, we need to like set up different types of walkers. How are we gonna do that? Because we have this random move system, and we're gonna want to essentially create a choose target system, and then a move towards target system. I see that. So we'll want a struct choose a target. Okay. So before I do this, we're going to want a choose target system. Does it make sense to make them bouncing off the wall more physical? I don't know. It's a good question. Like, should they bounce off the wall? And then in that case, I mean, in that case, I would just multiply the velocity by -1, or just like thud, they just stop at the wall. I don't know. We could try with both. I don't know if I have full like time enough this morning to implement the target walker. You want to rotate by 90 degrees? Well, I would multiply the like X or Y by -1. And then that would just do that. For the target, I need to choose. I need to like store the ID of the entity. Entities have IDs, right? I think they do. And I think I can get them. What I don't think I can do is get a random entity. I don't think there's a method for that. I can filter them, like find what's closest or anything else like that. If you join entities, you can get the entity from that. Yeah, I can. And then I can choose a random one from that vector. Because I could figure out what the length is, I think, maybe. I don't actually think I can get the length of it, because I think I looked through. I think I looked through the documentation for entities, and I didn't see like a length, like the number of entities in the world. I can figure that out myself. Like every time I eat, I just decrement the number of entities. If random, do logic, else continue. All right. Well, I think I'm gonna figure that out next time. But until then, let's try the bouncing off the walls. Let's just see how that looks. So in our not physics system, in our contained to arena system, we have this velocity 0. What I can do here is say velocity 0 dot x times equals -1 dot 0. So if you times equals a -1, it'll head back in the direction it came. Yes, exactly. Well, kind of. The y is still the same. So if it was coming up at an angle like this, it'll go back with that like same angle up. So it won't go exactly the same direction that it came in as. And we're going to do the exact same thing here. So dot y times equals 1.0. And it's actually -1.0 to reverse it. All right, let's go ahead and run this and see who wins. I probably want to have like a maximum size. for these, that way they can't. Yeah, so like that came up, bounced off, and now it's they're moving. They move a lot faster now. They're just vacuuming up all the food. Oh, pink is gonna win. Now it's just avoidance. Nope, there it goes. So this works out. It didn't get bigger than the arena, so it's like contained and trying to break out now. You're still thinking about vectors, not components that have vectors. Yeah, it gets a little bit it gets a little bit interesting with that. But yeah, we have our winner, the pink one. You can run it one more time to see who wins, and then I'm gonna have to call it for the morning. So since I have this time, I'm gonna go ahead and move you over there. You wonder who the winner was? It was pink last time. This time, it looks like it's going to be this light blue. It's quite pleasant to watch. Nice. It reminds me of like an old-fashioned screensaver. Oh, it can't get the other food. It's too big now. All right. So, light blue is the winner for number 2. Let's go ahead and take a look at our README, see what things we need to update. So we want to add in walkers that move towards food. And I think move towards a random entity that they can eat. Walkers can eat each other. We have that now. You don't see any object tearing on your end, right? No, I don't see it on my end. It might be that's what's my have bit rate is like decently fine. I don't think I can necessarily see exactly what the bit rate is on here. The previous view, I could totally see like, oh, I think it's 5,000. So like it's usually pretty good. That might be something interesting to think about, is like what that looks like off of the stream. But regardless, it is 8:15, which means it's time for me to sort of start getting ready for work. It isn't that bad. Okay, that's good. I do wonder sometimes between like a white background and a black background, which one would encode better for Twitch. This could be used as a Twitch giveaway app where each walker is one person and who won is the survivor. Oh, that could be really interesting to do. I could see that, where I could put the initial, or I guess you can't put the name of every person, but I could put the initial of every person in there. And you can see, maybe you can register yourself to go in. Oh man, there's so many cool things we can do with that. I'll have to think about like implementing that. Maybe after we're done with Nature of Code, we can start playing with that. All right. So I look forward. Nobody that I'm following is online, so I'm not going to do a raid today. So instead, I am just going to end the stream right now. I'm. I hope that everybody had a great time with this, and that you're all going to have a great day this Wednesday. My next stream is going to be Friday morning at 6:45 a.m. Mountain Time, and then we're going to implement those attraction walkers. All right. Well, with that, have a great day, and I'll see you next time.